Now in section 1b we're looking similar to 1a. Again, we have rational equations. This time it's a little bit of a level up. We're trying to solve them and find any restrictions or excluded values. So we're going to look at number 2 first. And number 2 again is a subtraction problem, so we're going to make that plus a negative so we don't have to deal with subtraction. We look at our denominator and we're trying to find a common denominator. And I know that 10 is really 5 times 2, and then times that n there. And then this one I have 5, and this one I have 5 and n. So on the far right term, I'm missing a 2 to have 5, 2, and n all be multiplied together in my common denominator. In my middle term, I'm missing a 2 and an n, so I need to multiply top and bottom of the fraction by that. So when I clean that up on top, I have 1 equals 2 times 3 is 6n plus, and then I have a negative 6 times 2, negative 12. And on my denominators, I have a 10n, a 10n, and a 10n. So since they're all the same, I can multiply both sides by 10n and make those go away. So I'm going to add 12 to both sides here, and I'm going to get 13 is equal to 6n, meaning that n is equal to 13 over 6. So n is equal to 13 over 6. My restricted values is what makes my denominator go to 0. And in this case, what makes 5n, 10n, or 5 go to 0? Well, I can divide by whatever number that is, and n is going to come out to not be allowed to be 0 in each case. Now in this middle term, you might be tempted to say, oh, well, n is not equal to 5 because I see a 5 down there and there's no n. Well, what could possibly make the number 5 turn into 0? Nothing. 5 will never equal 0, so you actually don't have a restricted value there. You don't have to worry about it. It only comes up if you have a variable like n in the denominator that you'd have to worry about it. So in the case of this one here and in this one here, both times n is not 0. Now let's slide over to number 3. Number 3 is a little bit trickier than number 2. What you'll see here is our common denominator is not as straightforward as it was in the last one. Before we get to that, again, we're going to get rid of the subtraction by making it plus a minus here. And if there were multiple terms up here, I'd have to distribute it to all of them, but there are not again, so we got lucky this time. Now, when I look at this denominator over here, I want to factor that because it will help me see if I have any common elements, and I'm hoping that there's an x minus 6 or an x minus 3 that shows up in those factors. So two numbers that multiply to 18 and add to negative 9. And so I can do my long list here, and if you're thinking through these numbers in your head, you might have come up with 3 and 6. They both need to be negative to multiply to positive 18, but add to a negative 9. So because this is a 1 out front, I can do one-step factoring, x minus 3, x minus 6. I can take my numbers and go straight to my factors. Cross that out. And I haven't multiplied the top here. All I've done is factored the bottom. I've just changed the form of the bottom without multiplying it by anything. Inconveniently, you'll see that we have an x minus 3 over here and x minus 6 over here, and then both in this last term. So we need to multiply top and bottom of these first two by the same thing so that we have an x minus 3 and an x minus 6 in each. So for this first one, we need to multiply by x minus 3 on the top and on the bottom. And in the second one, we need to multiply by x minus 6 on the top and on the bottom. So x minus 6 top and bottom. And now our denominators are the same, they're the same, and they're the same. And since they're the same on both sides, we can cross them out by multiplying through x minus 3 and x minus 6 on both sides of the equation. And remember, we can only do that now because we have an equation. There's an equal sign here. So that's what's new from last unit. On top, we need to distribute our 1. So that's just going to be x minus 3. Plus, we have to distribute our negative 1 to these, so it's going to be negative x plus 6. We have our equal sign, and then on the right side we don't have to multiply by anything, so we just write our 5x minus 5. Well, clean this up. X and negative x do cancel each other out. Negative 3 and 6 makes a 3 on this side. Keep working through this, add 5 to both sides of the equation, and we end up with 8 is equal to 5x. Divide by 5, and x is equal to 8/5. Now, when we go back and try to solve our missing piece on the bottom, our restricted values, this time it's going to be a little more complex. You'll see that we have an x minus 6 in our original equation. Let's look at that x minus 6 right there. And the value for x that we could plug in that would make that denominator go to 0 is going to be 6. Same idea over here. Value that we'd plug into that x is going to be 3. Now on this last one, we have two things, and we're always going to look at the factored form. So we're going to ignore this yet, but we're going to look at our factored form. And here, once again, it's going to be 3 and 6. And since we already have those written down, we don't need to repeat them. So our values at x cannot be, it's going to be x is not 6 or 3. So those are our restricted values for number 3.